So what is big data? Lots and lots of data. So big data refers to data sets that are large or diverse, too large basically for human, manipulation alone with traditional tools. So big data results in traditional data processing techniques being really not very effective. There are four major characteristics that characterize big data. So complexity, it's difficult to manage and build and can be built from different types of data. It requires specific means for transporting, storing, and analyzing data. Traits or other characteristics, things like the 5 V's: volume, velocity, variety, veracity, value. Variability is variety, really. Validity, data lineage, visualization, sovereignty. These are some characteristics that are often used to describe big data or data in the context of big data. The timing aspects, so the shelf life, the value of the data being produced decreases in value over time. So extracting data quickly is key for it to be relevant, and it's certainly something that big data is concerned about. And finally, something called gravity, which is an interesting idea. Doesn't mean seriousness. It means kind of like gravity in the context of, gravity in the cosmos sense. Data volumes increase and new sources of data become part of the big data data sheet. So more applications and use cases will be built around that data. So that's known as gravity, sort of like a moon, revolving around the Earth. You can think about it like that, where you've got large amounts of data with satellite applications and use cases around it as the data grows, that kind of gravity. So let's talk about diversity. Big data sets may be found from a lot of different types of data. The 3 types that are identified here, by the way, this comes up in the quiz. So structured data, where the data is stored and processed in fixed formats with clearly defined schemas. An example is when data includes dates, names, addresses, credit card numbers, things like that, where there's a definite structure. That makes it a little easier for processing. Unstructured data is when the form and structure of the data are not really known. This type of data is most difficult to process and analyze. So you may have some free format text or images, for example. Semi-structured data, this type of data contains tags, metadata, formal semantics, but doesn't conform to a specific data model. For example, a tab limited file versus lines from a customer's Instagram comments, where you've at least got some meta tags that you can use to categorize the data. So what are the 5 V's of big data? We'll be explaining each of these in the next slide, so don't remember the definition there. But just to identify the names, there's veracity, variety, value, volume, and velocity. These are in no particular order, but all data can be considered in this context. Big data has a shelf life and gravity, and it comes from many different sources of varying types. Understanding the characteristics of the data can be summarized what's known as the 5 V's. So it's basically summarizing characteristics of data. So the 5 V's are, okay, so value. How much value can be derived from the data? The value element of data set cannot be evaluated in isolation, but usually in the context of its use, as its value will be, will vary given time and applications. Velocity, so the speed at which the source system is generating new data. Understanding the velocity in the context of AIOps systems is critical, considering the real-time nature of AIOps. Veracity, how much can we trust? How much can we verify? How much can we trust the data? In evaluating data veracity, it's important to look at quality issues with the data, missing data, false information, maybe false positives, for example. Volume, the sheer amount of data, which in big data systems will be orders of magnitude more than other data repositories, such as relational databases. And finally, at least, last but not least, is the variety. So how many different types of data and data sources must be incorporated in the data set. In the context of AIOps, data will lean towards more variety as it relies on diverse and numerous data sources. So those are the 5 Bs. There'll be a lot of different sources. There's really typically 3 sources. AIOps systems require enough data produced by applications as well as infrastructures to understand the baseline of the system's operation and past issues, related alerts, trends, and so on. Because of this, data will usually come from at least 3 different domains. So one domain is application telemetry, so data coming from the application, data coming from the infrastructure telemetry, and also from monitoring tools, for example. So in the top 2, application and infrastructure, you're going to be looking for metrics, events, logs, traces. And with monitoring, you're looking at notifications from the tools and alerts, for example. So combined metrics, events, logs, and traces are sometimes referred to by the acronym MELT, which comes up on the quiz, by the way. Metrics are the values pertaining to a system's application at a particular point in time. Events are specific sequences of occurrences that take place within a system being monitored. Logs are the original data type in their most fundamental form. Logs are essentially lines of text or a system or application produces when code's executed, and traces, or more precisely, distributed traces, are samples of causal chains of events or transactions between different components in a microservices system or any system where you've got distributed activities going on, basically. So these are the essential types. Instrumenting everything and using MELT to build a fundamental understanding of system relationships, dependencies, performance, and health is a prime example of what's called observability. So how can we map AIOps to big data principles? The different types of data can be mapped and understood in the context of big data. Framing them in that context will help prioritize as well as design an effective AIOps architecture. So, for example, let's look at logs, which may include a lot of unstructured data, or may also include structured data. So unstructured data doesn't really fit into any database structure. This is kind of a definition. Has no rules or formats, considered free format, and cannot easily be used by programs. So you really want your logs themselves to be structured as much as possible. So this is how you can interpret the the 5 Bs in this in relation to logs. There's going to be an exercise in a minute where you'll be doing, suggested that you try to do this also for the other types of, MELT components. So this is for the logs, the L. So if you think about, first of all, log data can be very voluminous. So this can be managed using logs. So that has to do with volume. B equals volume, the value, so B equals V equals value. The value of log data can be highly variable and very contextual. Usually focusing on less verbose log levels can increase the value. 3, logs can be streamlined for processing or velocity when things are happening quickly. Or it's the accuracy and quality of the data. That's the veracity. Can it be verified? For verbose logging, better veracities occurs when using higher log levels that are less verbose, in other words. And finally, logs can encompass various sorts of messages. That's the V equals variety of information in logs is huge, and unstructured data. The unstructured nature makes it especially hard to extract value at scale. So anyway, that's how logs can be correlated to the different 5 Bs.